Thank you, and hi everyone. Thanks for joining us for Play Day, our virtual conference. Our next presenter is Kevin Weber.
Hi, so welcome. Thanks for tuning in to Enterprise Web Development with Play and Scala. Really excited to share some tips and tricks that I picked up on the Walmart Canada project. So before we get going, I'll just fly through my bio. My name is Kevin Weber. I've been a Java developer for 14 years, a Scala developer for about a year and a half now. I was the lead Play developer on the Walmart.ca project at Nurun Toronto. And some of the domains I've worked in are wealth management, capital markets, and e-commerce. So let's just jump right in. The audience for this talk, it's really appropriate for developers, architects, and managers. Some experience with Play and Scala is definitely helpful, but not required. One of the goals of this talk is to provide a high-level overview for people that may not have used Play or Scala yet. So what I'll be doing is providing some strategies to help with a few things, but mainly these three things. So maintaining high productivity during development across multiple cross-functional teams. So some of the architectural choices we make during development, especially with Play, it's a very flexible tool. So some of the architectural decisions that we make affect how our productivity looks when we start to scale out our teams, not just our technology, but our teams also. And we'll look at ways to integrate Play in enterprise environments. And really when I say enterprise environments, I mean environments with back-end systems of variable speed and reliability, different performance characteristics. So with that in mind, I'm going to offer some strategies to help plan for load, failure, and not just the technology aspects, but also changing requirements and other unforeseen circumstances. So it's a combination of technology and also a combination of people and teams. So really, there's a lot to cover. What I decided to do was focus on the edges, so focus on integration. So integration with interfaces, user interfaces and interfaces to back-end systems. And it's broken up into two parts. I'm going to start with talking about some interface architecture techniques. Then we're going to go right into integrating with back-end systems. So part one, playing with interface architecture, pun definitely intended. The objective of this part is to start to get a high-level understanding of your business domain and just talk about these issues. Sometimes they're not talked about in technical talks, and I just want to make sure that they get a lot of attention. Because the right front-end technologies are essential to create a quality user experience. And the right UI integration strategy is just as important as the actual technologies that we use. And there's a lot of ways to use Play. I've lived and breathed Play for about a year and a half now. And it can seem overwhelming. How do we actually integrate with different interfaces, not just user interfaces, but other tools? So I just want to share some of the analysis that I did with the team at Nurun. So the goals of interface architecture. I mean, first and foremost, we need to meet current UX requirements. So that's number one, is hitting the tactical targets that the business has on an enterprise project. But we also need to make sure that we're adaptable to future requirements and ever-changing UI technologies. Also, and this is really important, like I mentioned, the technical decisions that we make in enterprise development impact our ability to scale out a team. So we want to keep that in mind throughout our analysis and our planning and our development. So just as an example, the Scala team at Nurun Toronto went from 2 to 6 in a very rapid period of time, and the whole team grew rapidly. So it's a really nice problem to have, but it's something that we definitely want to address early on if we can at an app arc level. So why are we going to focus so much on interface architecture? Well, UX techniques and UI technologies move very fast. So it's a little different on the front end than say back-end systems. The back-end, different techniques tend to move a little more slowly and they're a little more methodical, but different UX techniques and technologies are very fast. So somebody innovates and then we want to definitely analyze if there's business value in that innovation. We definitely don't want to lock ourselves down into any sort of monolithic platform or architecture. So what I'm going to do is I'm going to give two options for interface integration. I'm just going to throw them out there and use them as a way to compare and contrast to almost totally different styles of developing interfaces and using play with those different techniques. So the first is a complete physical separation of your UI. So what does that actually look like? Well, it looks like play doesn't do quite as much. Play would basically just act as a RESTful API. You wouldn't use Play's Scala templates. You wouldn't do any front-end coding in Play itself. Each UI would be just another user of the API. And a UI can be a JavaScript framework, such as Angular, or it can be more pure JavaScript. It can be HTML5 and CSS with maybe some orthogonal libraries thrown in a mix. Maybe you want data binding. Maybe you want to use _JS for some functional JavaScript, which is very cool. So another UI could be a native mobile app, obviously, or really anything that communicates via standard web protocols. So in this case, each discrete interface would be its own application, would have its own repo, would have its own build and deployment pipelines, would have its own asset pipelines, could use radically different technologies. So it's great to slice up if you have a huge team and you want to slice things vertically, so different conceptual concerns go to different teams. And I'll talk a little more about that later. So you may have a wide variety of these UIs and different teams supporting each one. So let's take a look at it. This is a 10,000-foot conceptual overview of what this would look like. So let's start from the top and work our way down. We have obviously something in front of our applications. We're going to want Angular, JS, or checkout to be hosted by something. So I'm using Nginx in this example. So in this case, we have three completely physically separated UIs. We have a home page, and that's using Angular JS, and maybe the reason for that is has very reactive content, maybe server-side events, WebSockets. It's heavily trafficked. Maybe there's 10,000 users hitting it, within an hour, something like that, right? So the performance characteristics definitely come into play with the tech we choose for that slice. Then we may have a checkout page, and for whatever reason we've decided maybe it's higher in constraints, maybe it's use case or the UX requirements, we've decided to use HTML, CSS, and JS, just pretty plain, pretty plain. And then we have a mobile app that's in Android. Now this is sort of the middle where we start to integrate with Play itself. We may have some legacy HTML we've scooped up from an old app and we dump it into Play, and that's fine because maybe only 20 people are going to use it. It doesn't really matter, right? We just want to save as much as we can, get Play to act as host for this content. And then we have our REST API, so our services. So, and in the middle, I've shown a load balancer because, frankly, if you're implementing Play into an enterprise environment, you're probably going to be launching a high volume of instances of Play itself, so you're definitely going to want to have some kind of load balancing in place. Now, Nginx does this. I just use NetScaler as an example, which is a hardware load balancer. And then Play is going to integrate with backend services. So separate repos, separate assets, separate deployments, it's very flexible. So the pros, clean separation between client and server, conceptual, so home, checkout, logical, and physical, so just physically deploying these applications. So with that in mind, it's very easy to add new interfaces. They may not even be user interfaces. They could be business intelligence tools. It could be any consumer of your RESTful API. And with this strategy, it's very easy for designers, front-end developers, and server-side developers to work in familiar territory. So we're not expecting front-end developers to learn Scala to implement a Scala template. We're not expecting server-side developers to learn Angular. There's a very clean separation in the middle. But there's obviously huge drawbacks to this. The number one biggest drawback, I think, to this approach, and this is a pretty common approach, but you lose the power of Play routing in front, which is extraordinarily useful in multi-tenant applications. So, for instance, mydomain.com, you may want to look up requests from mydomain.com, and you may want to look them up in Redis or a database, something like that, and start to build context out for a tenant. Maybe you have you're hosting or you're doing something like this. So if you lose Play routing, you're going to have to provide that in some other way. Now, you could probably put Play in front of your physically separated UIs, but now it gets really complicated. And losing the power play routing is extraordinarily useful in applications that progressively build out pages. So any CMS app, anything that builds pages dynamically with dynamic URI lookups, play routing is incredible. So just a little fun factoid is that Walmart.ca is basically a giant CMS. So every single page on Walmart.ca can be themed and skinned through a product called Endeca. And business users can actually add pages on the fly. And whenever a request comes through Play, it actually does a dynamic URI lookup out to Endeca, pulls out some JSON content, and then we've actually used Play to convert, to transform that JSON content into chunks. We call them cartridges and templates, chunks of a page, and then render the final HTML. So very useful to have play routing in that scenario. We also lose the ability to pre-render any data. So all dynamic data is going to basically be coming through the API, so it leads to chattier apps. So that's option one. I'm going to throw another option out there, and that's not a complete physical separation of the UI, but it's instead a logical separation of the UI. So I'm going to throw out a new term. Maybe it's not new, I don't know. I think it's pretty cool. MSPAs. Sounds funny, multiple single-page web applications. Play would wind up acting as a host in this logical separation using this quote-unquote MSPAs technique. Play would essentially act as a host for multiple single-page web applications. So you still get some of the logical separation and without the physical separation. You also get the conceptual separation. So each SPA, so in that previous example, home and checkout, in this case, these would just be individual SPAs. So still mostly REST from the UI to Play. So it's still mostly service calls to populate dynamic data. But it's a little, I'll go into it a little more, but you do have a little more flexibility to actually pre-render some data. So I'm going to throw out some examples, and I'm going to use AngularJS for the examples just because I happen to love AngularJS, and I think it's a great UI technology that not only is a framework, but is also very adaptable to adding libraries such as _.js, things of this nature. So what would this logical separation look like? Well, it looks fairly similar to the physical separation, except now we have Play framework hosting home and checkout. And the Scala templates provide that wrapper for our AngularJS views and routing. So basically, we're using Scala templates as hosts, as sort of plug and play for SPAs. And you can have as many of these as you'd like. And you may also have pure Scala views in other parts of your application. It's cool because you're not basically giving up all the power of Play. And you can still be very flexible with how much or how little of Play's views that you actually use. So in this case, we would have it likely a shared repo. I'm just a shared repo for now. We would likely have shared deployment builds. And Scala view templates would be used basically as pluggable containers for MSPAs. Now the reason you might have noticed that I have this JS and CSS bubble up in the Nginx box, and that's to kind of point out conceptually that you definitely don't want to be hosting static assets off of Play itself. It's just not built for that. So although this is a conceptual overview, I just want to really call out the fact that you want to move static assets as close to your customers as I'm hoping you're using a CDN for enterprise development. You're going to want to use something like Akamai. There's a lot of different CDNs. But the moral of the story is just absolutely don't serve up any static content off of Play. Just get it as close to the client, the customer as you can. With that in mind, that you'll also have to figure out a cache-busting strategy, so asset fingerprinting, which I'll talk just a tiny little bit about later. But I'm super excited that this is now part of Play 2.3. So some considerations. Why not just a single page application? I mean, that makes sense. Makes sense when you say it, but when you actually start to think about it, it doesn't quite make sense for an enterprise application. First off, Enterprise dev teams can be huge. Enterprise applications can cross a lot of different conceptual boundaries. And one UI stack may make sense for one component, but not another. So smaller teams, multiple single-page web applications lead towards smaller teams. So a large e-commerce project might have a checkout team, a product information team, an admin team. It could have a lot of different cross-functional teams. And each single-page web application probably has a different use case. So the performance characteristics are probably radically different across these different slices of your architecture. So sort of doing this monolithic big bang, I guess it was a thing in Rails. It was never a great idea to begin with. So it's worth spending some time to think about how you actually want to slice your site out. So just don't go big bang. Start to design it based on the different performance characteristics of each conceptual slice of your site. So modular spas, or spas in general, provide very fast, responsive, and rich user experiences. A monolithic spa is very cumbersome to develop on a large team. So multiple single-page web applications allow multiple cross-functional teams to form around these different conceptual site boundaries. So I just wanted to go through a very simplified HTTP request and how this would look. And there's a couple things to call out. First off, if you notice the domain, the URL and the URI, is in that first HTTP GET is pointing to admin settings. Yet we're still going to return HTML for just admin. So no matter what nested child view is requested, say that a page is bookmarked, whatever, Play really doesn't have any concept of these child views. It only has concept of the spa itself. So if you're thinking about a template, Play can speak at a template level, but it can't speak at a particular view level. And I'll show you a few examples of how to slice your site up to make that a little easier. But basically, you're gonna render this template, the spa, container, then obviously JS and CSS, however you've actually architected the HTML itself. All of those are going to load, maybe parallel, maybe not, however you've designed it. And then you're going to issue a lot of HTTP calls for some JSON, because that's really how spas communicate. So what would a routes file look like in this example? So really there's two things here to really pay attention to. And the first one is admin. So that's the main use case for this. Is the main navigation point into a spa would be at this very high level. And then we may want to put admin login as a separate page outside of Angular for some reason. Doesn't matter. But routes are in order. So if you want anything to render a nested child view and not have Angular handle it, just make sure to put it in front of this very last thing that I want to call out, which is a quote-unquote Angular wildcard. So what it means is that if Play actually does wind up trying to serve a request for a nested child view, that it doesn't care. It's basically just going to render the same template as it does for the parent. So what would your controller look like? So in this case, we have an index action. We have an Angular wildcard action. The thing to keep in mind here is both of them, again, are going to render that same views.html.admin. With the Angular wildcard action, you may be able to do a little bit more operations, but for the most part, it's going to render the same thing. You could have these two actions pointing to the exact same response, and it would work fine. So the other thing to call out is that regardless of what the URI is for the Angular wildcard, that's actually all the routing is going to be handled client-side in the browser. So I'm going to actually jump over to that now. So don't be scared if you haven't worked with AngularJS. What I want to point out is that Play has its concept of views and controllers, and a lot of newer SPA frameworks or frameworks like AngularJS, they also have controllers, they have views, they have routing, things like this. So it's using them in tandem for their strengths, which I really like. So in this case, something to call out. So we'll start with admin config.js. And we have two route provider. So basically what we're doing here is we're configuring this ng-admin app, and we're setting up some routes on it. So the first one is admin. So basically that's pretty straightforward. It's going to render and it's going to plug index.html into your view, and I'll go over that in a second. And then you also have a child view, which is in min settings I'm using as an example. So before we go any further, let's just duck down to the admin template Scala HTML so we can start to see how all this would fit together with Play, serving up multiple single-page web apps. So if you notice, the key thing to look out for is this is a pretty typical view template, but we have a section in here with ng-admin. So we have an ng-app, an ng-admin directive, and we also have an ng-view directive. So really what that ng-view is doing is it's acting as a placeholder for whatever is in either index.html or settings.html, depending on what URI is being navigated to at the time. So really the key thing to keep in mind is that all of your routing is going to be in these smaller child HTML views. And as long as the navigation is actually happening within those, Angular is going to intercept it, and it's going to use its own routing. And if it's outside of that, so if you put some links in that header, then those links are actually going to make a full server-side request, and Play is going to do that. Play is going to handle that route for you. So it's a cool way to kind of slice up a site. So how would that actually look? Let's just look at very high level how this would look. Is if we had a page that was sliced up using that template that I show below, basically anything within that header, Play is going to handle navigation because it's outside of the ng-app declaration. Anything within the ng-view, so as Angular is inserting this dynamic HTML, then anything within the ng-app directive, Angular is going to handle that navigation. So that's the way that you could use Play as a host for multiple single-page web applications. So there's some pretty huge pros to this approach. The first is that you still get a lot of the benefits of the completely physically separated UI, but now Play can route requests to specific SPAs. You can continue to work with Play in a very familiar way, so your authorization, authentication, any non-functional stuff, quote-unquote, that you want to do can still happen within Play. You're not shifting your security and all of the cross-cutting concerns off to a UI that may not have as good of an implementation for that as Play does. And then you can still use Angular.js routing and controllers at a SPA level for very ultra-responsive UI. So you're using Play for what it's really good at, and you're using Angular.js for what it's really good at, which is cool. And you can continue to use Scala templates. So you can pre-render some data. Now, Angular.js really does work in sort of a pull workflow, so it wants to pull data, it wants to progressively enhance pages. But if you've got big chunks of data, you can pre-render some of that. Now, that's for newer Angular.js developers. It tends to be that you want to pre-populate everything, but it's really you want to only pre-populate data that's really going to reduce your HTTP traffic, really provide that responsiveness. And the other pro is that server-side developers are still responsible for the overall app architecture. So we're basically setting up these containers for front-end developers to plug their components in. So the characteristics workflow-wise, it still has a lot of the benefits of the completely separate UI. So front-end developers work with their strengths, back-end developers work with their strengths. But now there's a little bit of this mix in the middle. It's not so separated. So you could have a front-end developer that starts to get into Scala, which definitely happened at Nurun Toronto. There's a couple of JavaScript developers that really loved working with Scala. So they were able to still kind of get their hands dirty and work on a lot of the CMS functionality that I spoke about earlier. And there's back-end developers that were like myself. I'm into front-end technology, so I like, I like blending them a little bit, but your mileage may vary and all of that. This is just my opinion. So there are a few cons, and that's just the additional complexity of having extra routes in Play for these, I call them URI pass-throughs, the wildcards. And your HTML is coupled to server-side code, which isn't bad. It's not like this monolithic app where everything's kind of all of these conceptual concerns are crossing over everything else. Just a little bit of, you may get some model tier classes bleeding in the Scala view definitions, but not really a big deal. So is option 2, multiple single-page web applications, the winner? I like it. I think it's ultra responsive. I think it's a very cool way to architect, use both the power of JavaScript frameworks, JavaScript libraries, and also use Play for what it's super powerful at. So it's a cool option. So check it out if you're looking at doing something like this coming up. So we're going to shift gears. This is part 2. So now it's playing with external systems. We're going to build upon just a touch what we talked about in part 1, but for most part this is the integration with our external backend systems. So enterprise challenge. What makes developing in the enterprise, aside from abstract proxy, bean factory, whatevers, that's not enterprise. What enterprise is working with different backend systems that have totally different performance, so speed, reliability, characteristics, and having to build around that. So it's not just a happy path. You don't have complete control over everything. So you have services that are slow or fast, flaky or reliable, but really the data that they contain could be optional or could be completely critical, and the characteristics of them may not line up to reflect that. So that's a big challenge, and we're going to talk about some ways to make sure that you don't fall down any deep holes. So when you start analyzing dependencies, when you start working on interface architecture, the key thing is to let the sort of user experience in the design guide you towards that understanding I mentioned earlier of your business domain. So you really want to understand, based on your user experience, what kind of data you need. And then you need to start doing sort of a deep dive, doing a decomposition of all your external systems and deciding how you want to build that out. So when you start doing an exercise like this and inventorying all these systems, it's not just good enough to think, oh, okay, that system X seems pretty cool. Doesn't seem too flaky. Well, have you actually thrown load at it? Have you found out what its threshold is? So really it's not just a sort of gut feel. It's actually testing a lot of these external services within your enterprise overall ecosystem, and then starting to assign characteristics to each one of these services. So in the case of Walmart.ca or any e-commerce site really, you could have, let's just use these 3 as an example. You could have a product availability service, a reviews and comment service, and an order placement service. And the first one it's slow and reliable, but it's absolutely critical. So the slowness might screw us up at some point, so we'll have to address that. You could have a reviews and comment service, which is super fast, but it's hosted by a third party, so it's flaky. Luckily, it's optional. So, I mean, you can trust third-party services if you'd really like to. I recommend just assume all third-party services are flaky and kind of program very defensively around those. And then the very last thing could be an order placement service, so it could be very fast, very reliable, and also very critical. So you definitely, this is the last part of your e-commerce site that you want fail whaling, is order placement. So let's look at a couple different scenarios. So scenario 1 is, what do we do when speed and reliability are the most important factor? So the speed of the data is, we can live without accuracy on the data, but we really cannot afford to fail whale a page if we can't get this data. So really we're going to need to cache. We're going to need to cache data from slow or unstable services, but accuracy may suffer when data is cached. So for instance, if you cache product information, you may wind up rendering a stale out of stock status. So if you're not caching, calling the slow service must be async to prevent blocking the whole page from loading, and that's very important. So scenario 2 is when accuracy of data is the most important factor. So accuracy trumps speed and reliability. It sounds weird, but there's some data that just absolutely has to be accurate. So in this case, one option is to load it asynchronously. So accurate data from slow services can be progressively added to the site without blocking the whole page. So you may load some slow stuff below the fold. You may just decide that the accuracy is more important than it showing up at all, right? So the real issue with loading in real time like this, and especially progressively enhancing a page, is that there's absolutely no guarantee that asynchronous data is going to be returned within a reasonable time frame, or ever. So we have to, I'll get into a few techniques to guard against that. And it may, if accuracy is the key factor, then it may limit your ability to pre-render data. So pre-rendered data must come from fast, reliable data source such as a cache or a very reliable service, because anything that you're pre-rendering is going to block the whole page from loading, and basically it's just going to make your site feel super sluggish. So I just want to throw some quick caching tips into the mix randomly. Choose your caching strategy wisely. Caching per play instance can be very dangerous, so you definitely don't want server X returning a different price than server Y. Oops. Not that that ever happened to us during testing. Also think of cache busting. So this is a little outside the scope of this talk, but you're definitely going to want to have an API to invalidate cache server side. If you do cache at regardless of whether or not you use a distributed cache or instance level caching. So if you use instance level caching, you're going to have some mechanism to visit every single instance and bust their cache if things change on the back end somewhere. So that's pretty complicated, again, outside of the scope of this talk. Even if you have a distributed cache, you just have to think about, okay, if I'm caching data, if it changes, what's the worst case scenario? So just putting it out there to think about. And asset fingerprinting for static cached assets. Again, this is less of a thing now with Play 2.3. For us, we kind of had to roll our own, but wonderful to see it in Play 2.3. So what's the ideal approach for dealing with external systems of variable speed and reliability? Well, pre-rendering accurate data in real time from fast services sounds good to me. Progressively enhancing UI with accurate real-time data from slightly slower services, but ones that we're fairly confident about, that's the second best approach. The third approach would be to prefetch cache content from unreliable services, but then again you get into having to figure out a good strategy for cache busting, figuring out a good strategy to make sure that the consistency of your data it's very consistent. You don't want different requests returning different data depending on which instance of play they hit. That's awful. The other option, number 4, is to just completely omit a chunk of a page. If data accuracy is too important to prefetch and cache, and the data, that part of the page isn't totally required by your user experience, just omit it. Set some performance thresholds around that chunk of the site and just leave it out. Now the very last approach, you want to avoid this at all costs, but that's fail whaling a page or fail whaling a whole spa. What you really don't want to do is set your site up in this monolithic way where a single service is actually going to bring down the whole site. And this is very common, but we don't need to do it anymore, so don't do it. If your sort of sad path is fail whaling your whole site, then go back to the drawing board, figure out a new approach, because that's going to lead to a really poor user experience. So here's an example of page zones. We've got a sweet little circle up there, we've got a diamond, and we've got a star. So the circle is outside of the angular zone, so we can cache and pre-render it. The diamond is, we're going to load it async. It's within the angular zone. If it doesn't come back, we're going to have to fail whale. But now that non-functional requirement, that business logic, is kind of outside the scope of play. And now you have to start thinking about that on the UI level. What's going to happen if this data doesn't come back in 1 second or 2 seconds or 5 seconds? And luckily, the star, we can load it async. If it doesn't come back, it doesn't come back. So you may need to slice if you're doing this multiple single page or just a single page application. You may need to slice up your templates to make sure that you can pre-render the important stuff across all of the nested child views. But that's really up to your user experience requirements. Okay, so that's one sort of set of tips, is just understanding the data that you need. So now we're going to get into a few tips on resiliency. The first thing I want to talk about are circuit breakers. These are absolutely wonderful. I want to thank Nilonjan from Typesafe for introducing these to our team during code reviews. We were lucky enough to work with Nilonjan at Nurun Toronto. He came in for pair programming. So I'll just read this quote. A circuit breaker is used to provide stability and prevent cascading failures in distributed systems. These should be used in conjunction with judicious timeouts at the interfaces between remote systems to prevent the failure of a single component from bringing down all components. That's a mouthful, but they're awesome. So let's look at what they actually are. So this is a very simplified circuit breaker diagram. What we're looking at here really is if you wrap, let's just use the term wrap. You're wrapping an external service call in a circuit breaker, and the circuit breaker is now monitoring certain performance characteristics of those calls. So when everything is going well and the performance of those external systems is within your predefined threshold, whatever you've decided, max number of failures and max timeouts, things like this, the circuit breaker is in the closed state, everything is hunky-dory, the data is being returned, it's being grabbed from the server, it's being sent back to your UI, everything's great. It's in the closed position. The circuit breaker really doesn't do a whole lot except kind of keep an eye out. But, your performance is kind of bogging down on one of these external services. Now you've tripped the circuit breaker. So what does that mean? So when the circuit breaker goes to the open position, basically all of your calls start failing to that service. But the good news is that rather than just continuing to fire out requests to a dying service, and then you get bogged down, you start to tie up threads and things are slow, you're actually failing instantly. So your UI is still responsive. You're basically sending, you're going to want to catch those exceptions too, because now instead of catching some kind of timeout exception from an external service, you're going to be actually dealing with circuit breaker exceptions, open exceptions, which is great because now you can start to plan out. It forces you to start to think about what happens when your circuit breaker trips. And what ends up happening is basically the circuit breaker stays in that open position for a period of time, and then it attempts to reset itself. So you programmatically decide how long a circuit breaker stays open for before it tries to reset itself back into the closed position. So when it's in half open, it'll send out a request here and there. Not all of them, but it'll try a few, and when the performance characteristics of those calls start to fall within what you've already defined, then the circuit breaker is reset and it's back in the closed position. So what does one of these things look like? Well, really the thing to kind of keep in mind with circuit breakers is you really should wrap every single external call, any single request to an external system in a circuit breaker, because you just have to assume that things are going to go wrong. So, if you're on a big enterprise, ecosystem, not all services eventually, even a database, everything is going to eventually experience some kind of failure. So if you start developing these circuit breakers around all of these external dependencies, you're going to start getting to that destructive testing, getting to that quality very early on in your project. So in this case, you can see what I was talking about. We have a blocking circuit breaker. So I'll get into thread pools a little in a second, but basically I've set up this blocking circuit breaker, and it protects all of the operations that I do on my blocking pool out to external blocking I/O. And I'm pulling out some max failures, call timeout, reset timeout from a property file. So this can be tuned in different environments for testing especially. And when the circuit breaker opens, I mean, you can provide a callback for pretty much anything. You can send it some alerting operation. Maybe something cool to do would be if it's for something hyper important like placing orders, you may want to add that to a queue. You could use an actor. That's a little outside of the scope of this talk, but at the very least you're going to want to send out some kind of alerting to your ops team just to say, hey, we're experiencing some problems with the service. And so how would it actually handle failure? Well, you're going to have some kind of catch open circuit breaker function, and you're basically going to wrap your action calls within that. So when you start to, you're basically coding identically the same. You're wrapping this dangerous if you look down below, tying it together, you're wrapping some dangerous operation with the circuit breaker, and then you have a future result. And really what you want to do then is then catch any open circuit breaker exceptions, but otherwise you're going to basically treat that future result as you would with anything else. So just to kind of recap circuit breakers, they prevent failures from overwhelming strained services and cascading. And what I mean by that is now when you start to detect that things are going amiss with a certain service, rather than continuing to hammer it with the load, you're giving it a chance to kind of heal, right? So you're blocking at your app. You're not continuing to hammer it with traffic. So, you know, I mean, most users, right, they experience a problem. What do? They refresh the page. So that sends even more traffic off to your dying services, and then it causes even more problems. So these things really halt that sort of cascading failure, right? Nip it right in the bud. It also the circuit breakers guide the development of strategies to address the inevitable failure of external systems. The inevitable. All external systems will fail. Just as everything you develop will eventually fail, it's just the nature of the game. So rather than kind of leaving that as somebody else's problem like an ops team, it really gets pulled in. So now there's some people that obviously think that, okay, a database failing, that shouldn't be a concern of application architecture, but it really is. I mean, especially in an enterprise environment, just assume the worst, program defensively, even you don't want to be like overly paranoid, but at the same time, paranoid development leads to very robust error handling. So prepare for failure early in a project. It also guides the exercise that I did earlier, because when you're starting to get into circuit breakers and starting to think about failure, you really want to start to understand your external systems. So you'll probably then start to test them out. You'll probably start to throw some load at them, see how they respond. It guides the design for failure, and it leads towards modular design. So the second exercise we went through, looking at the page, so this isn't just a server-side concern. This bubbles up all the way into the user experience. So what happens when data from service X isn't coming back? How does that impact my page? Can I omit that chunk of a page? And circuit breakers provide a very clean way to intercept those exceptions rather than just kind of throwing your hands up in the air. Systems are failing. Now the UI is sluggish, right? What do? Now we're going to fail whale the whole app. You don't want to program like that. And it guides towards early destructive testing. So there's some other cool stuff that Dana Harrington, developer at Nurun Toronto, did with circuit breakers for testing. Very cool, and maybe at some point we can throw some example code up online. So execution context. We've talked about circuit breakers, and you may have noticed at one point I had a blocking circuit breaker, and it was using the executor. It was using a blocking thread pool. Sorry, a blocking execution context. So now let's talk about what these actually are. This was one of the most trial and error portions of Walmart.ca, is just tuning execution context. So really, they're just an abstraction over threads and thread pools. So an execution context is basically just a thread pool, but you don't have to do any of the heavy lifting. You just basically tell Play, here are the characteristics I want for my thread pool, and then it'll figure out how many threads to assign to it. The default execution context now, I believe it's fork join. And somebody can correct me if I'm wrong, but I'm pretty sure that using fork join, each thread has its own queue of work, and if the queue runs dry, then the thread starts to steal work from other queues. So I also believe there's a thread pool executor. I think the only difference between these two is that there's no work stealing with thread pool executor. But somebody, if I'm wrong, just correct me, and I'm happy to take all of that back. I love this quote. This is from a talk that James Ward did. Lots of various knobs you can turn to tweak. And it's absolutely true. And some of James' blog posts are really what helped me kind of get a handle around execution context. So thanks to James for posting those. So really, if your code is completely non-blocking, you can simply use the default execution context. You don't have to worry about it. If you're non-blocking, that's what Play is designed for. Use the default execution context, you're golden. The thing is, in any non-trivial enterprise app, you're going to need to tune. You're going to do some blocking I/O. You're going to do something that's memory hungry. You're going to want to start to divide up your work into different types of work, and I'll get to that now. So what is an execution context? What does the config actually look like? Well, first I'll just go over basically what these values mean in here. So we have our default dispatcher, which is fork join. We have a blocking I/O pool, and we have a memory-hungry pool. So basically what this is I'm just setting up different execution contexts for different types of work. And then I can start to tune each one of these individually. So the values are this. It's very easy to kind of grok. It's the parallelism factor is used to determine the thread pool size using ceiling of available processors times whatever parallelism factor that you provide. The resulting size is then bounded by the min and max values that you provide. So what we noticed and what I noticed is that in some cases you don't need to provide a parallelism factor, just bound min and max at the same value, and then your threads are fixed. And that obviously has some advantages, some disadvantages. I won't go too deep into them. But in then other cases, it's better just to kind of let play handle it based on the number of available processors. So if you have some memory hungry operations that you're doing, maybe you don't want to have too many threads available to handle those. Maybe it's a little better to block rather than run the risk of running out of memory. So what would this look like in code? Well, you basically just set up, looking at threadpools.Scala, you'd set up a couple execution contexts, implicit vals, really easy. Now you can import those anywhere that you're needing an execution context for futures, actors, anything. And you can either use those implicitly or you can actually query them in explicitly and use different pools within the same class. So it's very cool. So really the number of threads available, I mean, this is a lot of trial and error. I'm not an expert on how to tune these. I just know what I kind of went through, so this is very much your mileage may vary. What I recommend is that you want to try tuning them. And what we did is that we just put play in a bunch of different environments with different configuration, and then we threw different types of load at it, and we just watched how it performed and came to our final production values. So you want to make sure that you've got enough threads available to really max out your cores, but you don't want to run out of memory and crash. So it really, the essence of this is that it all depends on the type of data that you're processing. And like I said, create different pools for different types of work. I've already went over these, so I'll kind of skip some of these bullet points. Tweak until you balance performance, memory, all of this stuff. And just remember to be very nice to your ops team, because they're going to say, and I just want to thank the Nurun ops team for all the hard work that they did on Walmart.ca. So, the end, recap. So thanks very much for sitting through all of this. I hope that you got a few pointers that will help you if you're about to do a project of this magnitude. The Walmart.ca project was absolutely incredible to work on. I've worked with a lot of different technologies over the past 14 years. And by far play, not only was it the most fun to use, the most conducive to a good user experience, but it was actually the smoothest production implementation I've ever experienced. So on the actual production launch day for Walmart Canada, I had my time blocked off till 7 a.m. the next day. I was home by, I think it was 11:30 at night previous day. I mean, that's really unheard of a project like of this nature. So we partied early. It was absolutely fantastic. So that's why I just wanted to talk around sort of the edges. That's where some of the complexities were. Play in the middle, very easy to use, well documented, and you're not going to run into any significant risk. You just have to really think about how you want to architect. So what does the enterprise mean? Why did I call this Enterprise Web Development? Well, enterprise development is a little different because your teams are huge, so you want to stay flexible. You don't want to develop this big monolithic application, because you never know when a new user experience requirement is going to come along and push you down a new path. So you just want to keep that in mind, keep the flexibility in mind. And your applications really, in an enterprise anywhere, start to reflect the organizational structure. When you start to fight organizational structure, that's when you have a bad time. So really some of these tips and techniques will help you kind of architect for the organization. So it's a very empathetic way of architecture. So if you have multiple product owners, multiple schedules, really start to slice your site up to reflect that. Be empathetic to the structure of the organization. If you have multiple product owners and you're delivering this big bang monolithic sort of application, you're going to run into issues. And the last thing is that there's multiple skill sets on an enterprise team, 20, 30 developers. This is a lot different than a 2 or 3 person startup team. So scaling out a team big bang in a single technology is very difficult. So your architecture should reflect the fact that you may need to make compromises along the line. So hopefully some of these tips that I provided kind of help, not just scaling out at runtime, not just providing some stability and some resiliency, but also being able to scale out teams. Thank you very much, and hope you enjoyed. So now I'll take questions. I'm going to stop sharing my screen.
Thank you, Kevin. That was fantastic. Really appreciate you sharing today. Yeah, we do have time for a few questions. We're running just a little bit over, but let's see here. We might do some quick ones. Can you, so someone has a question about where they can read more about execution context. Do you have any advice?
Yeah, I would suggest Googling for some of James Ward's contents. So James Ward wrote quite a bit about execution context. There's actually one in particular that I believe it's execution context tuning for database applications, something along this line. I wish I had a link for you. But yeah, I would start there. And I would also recommend taking a look. Nilanjan has a new book out. And Nilanjan taught me a lot about execution context, so I haven't got a chance to read to the end of his book, but I'm sure that there's a lot of great stuff in it, and that's what I'm going to be doing on the weekend is reading his book. So yeah, I would actually recommend both of those approaches.
Nice, thank you. There's also a comment and a question about caching. Do you, along the lines of resources, do you have any recommendations on books or other sources about cache planning and caching strategies?
No, but that's a great question. And what I can do is I'm going to talk to some of my colleagues at Nurun and see if they have any recommendations. So Ankur Mathur, our architect, is kind of who I went to for caching advice. So I'll touch base with him, and if there's contact info, I'll definitely get back to that person.
Cool. All right. Yeah, we'll be sending all of the questions your way. So if you want to follow up with people directly, you can certainly do so once we wrap up.
For sure.
And so if your question wasn't answered, which you guys sent in a lot of great ones, Kevin will be following up with you via email, and you can take some of these conversations offline. Thank you all for tuning in today, and thank you, Kevin, for presenting. We're going to take a quick break in our virtual conference now, and we'll see you back online in about an hour. So thanks, Kevin.
I just saw a comment. I'll cut you off. Akka Concurrency
is
one of my favorite books. Akka Concurrency is one of my favorite books by Derek Wyatt. So Sean just posted that, and I absolutely highly recommend that book. It taught me quite a bit, especially about resiliency. And the Akka docs are phenomenal. So if you want to dig more into that, I would definitely take a look at the online documentation and take a look at Akka Concurrency. So
Great.
Thanks to Sean for that.
Cool.
Okay.
All right. Well, thanks, everyone, and we'll see you back online in a bit.